Hi everyone, this is Mrs. Jackson, and I'm making this quick video on the 2.3 Warm Up 1 for those people who were retaking the MCAS test this week and missed going over this warm up in class. Okay, so what we're trying to do here is follow up on the 2.3 notes on factoring quadratics. Some people learned that in 9th grade Algebra 1 and some people didn't. Some people remember, some people forgot, so I'm reinforcing that previous material because we're going to be factoring quite a bit here for the rest of the year. All right, so first things first, this problem here is a quadratic equation. It's got an equal sign and it's called a quadratic equation and not a function because it does not have two variables. So we're down to just one variable, the x. However, it is very related to a quadratic function. So if you think about a quadratic function in standard form, which we've already gone over, that would be y equals ax squared plus bx plus c. So this truly is a function, meaning it has an input and an output, and we would graph that on the coordinate plane in 2 dimensions. How this is related to a quadratic equation is that we're putting y equal to 0. So if I put this y equal to 0, I've dropped my output and I'm just down to a single variable equation. Now what's happening here? If we look at the coordinate plane everywhere along this x-axis, y equals 0. Y is not positive, y is not negative, y equals 0 all along that axis. So when we are solving for the values of x here in a quadratic equation, we're actually solving for the x-intercepts. So if I had some kind of random quadratic or parabola, we're solving for these x-intercepts right here where it crosses the x-axis. Okay, before I go over how to factor a quadratic equation, I just want to take a moment, and you don't have to write this down in your warm-up, but I wanted to review with you what it looks like to multiply two binomials together and see what happens. You may or may not have done this, what looks like a Punnett square in freshman year, but it really is for us just a graphic organizer, and I just want to show you, I'm making up a problem here, 2x plus 1 times, say, 3x minus 2. So say this was a quadratic we were trying to solve. This is already factored, and so it becomes very easy to solve for these values of x using the zero product property, where I could put both of these independently equal to 0 and solve for x. But I want to go backwards and show you what's happening. So this is just a graphic organizer, and we could use it to organize our distribution, really. So 2x times 3x is 6x squared. Negative 2 times a positive 1 is negative 2. And I'm going to change colors here. 2x times a negative 2 is negative 4x. And 3x times positive 1 is 3x. And so what we end up having here is two like terms on the diagonal, and they combine. And this is what forms our trinomial. So if I put all of these together, I've got, you know what I just noticed? I forgot my square here. So if I put all of these together, I've got 6x squared, and I've got these two like terms, 3x minus 4x, and minus 2, and those two are going to combine, and they're going to give me that single x term in the middle. So we've got this negative 1x. And so the whole idea behind factoring a quadratic is that we would start with this, and we need to get back to these binomials. And so the entire procedure that I'm going to review with you is all about finding these two terms that make up this negative x, and we're going to rewrite this middle term with these two terms in order for us to get back to these binomials. Okay, so we're back to a quadratic equation that we're going to try to factor, and the first thing is that we need that y equal to 0 on one side. And so we've got to get that 8 out of there, and the way we're going to do that is subtract it. And when I subtract it from the left side of the equal sign, I'm going to tuck that under its like term, which is the negative 13, the constant. And then I end up with that 0 on the one side of the equal sign, which is exactly what I want. Okay, so here is the procedure that we're going to follow to factor a quadratic. First things first, try to factor out any common factor out of the coefficients and the constant here. If you can find something that's common, go ahead and lower your numbers and factor that out first. In this case, we can't. But you would do that if you could. All right, so the first things first, we have to be in standard form. That means descending order of exponents. We've got our x squared term, our x term, and then our constant, and that's what we have here. And then you're going to identify your a, which is the coefficient in front of the x squared term, I'm sorry. Our b is the coefficient in front of the x term, and our c is the pure constant. And what we have here is an a equals 10, b equals 1, c equals negative 21. So the procedure is going to be to find the product of AC. The product of AC is negative 210, and b equals positive 1. So what we're looking for here is two numbers that multiply together to give you negative 210, and that sum together to give you b equals positive 1 here. And so negative 210 is kind of a big number. And I can't think of off the top of my head what the two factors would be that are only one digit apart from each other. So what I like to do is just, instead of multiplying that 10 times the negative 21, I actually break down the 10 into 2 times 5 and the 21 into 3 times 7. And one of these numbers, I'm not sure which one yet, but one of them has to be a negative. So I'm just going to put a negative up front here. When the numbers are kind of broken down here, I try to look at it and see, is there a combination of products that I can make that would be only one digit apart? And the first thing that I see here is 5 times 3 is 15, and 2 times 7 is 14. So those two numbers, when multiplied together, are going to give you that 210, but when you sum them together, we would get a 1. Of course, obviously 1 has to be negative. So which one do we want to be positive and which one do we want to be negative? We want a positive 1 ultimately out. So the 15 is going to be positive, and the negative 14, that's going to be our negative. That's going to multiply together to give you that negative 210. But when you sum them together, you get positive 1, and that's what we're looking for. So that's what I meant on the previous slide, is we're looking for these two numbers that we're going to replace this 1x with, okay? All right, so once we have those two numbers, we're going to rewrite our quadratic. I'm going to write my 10x squared first, my negative 21 equals 0, and I'm going to replace that positive 1x with my 15x minus 14x. And it does not matter what order you put those in. Okay, so you could put negative 14x first, followed by positive 15x, or vice versa. But the main thing here is that we're replacing this positive 1x with these two terms that are going to be combined. All right, now what we're going to do is something called factor by grouping. We're going to look at the first two terms separately, and we're going to factor out the greatest common divisor. And in these first two terms, you can see both the coefficients are evenly divisible by 5, and both of the variable terms are evenly divisible by x. So I'm going to factor out a 5x, and essentially I'm using the distributive property in reverse here. And the distributive property is all about multiplication. So if I'm using it in reverse, I'm basically doing division. So if I have 10x squared divided by 5x, I have a 2x left. And positive 15x divided by a 5x is plus 3. All right, now looking at the next two terms, I can factor out a positive 7 evenly, or a negative 7. And you're going to need to determine which one you want. Do you want a positive 7 or do you want a negative 7? And the answer is you want what's remaining in the parentheses to look identical to this. So if you look carefully at that, that's going to tell you that we want to take out a negative 7. By doing so, I'll end up with a positive 2x here. And we'll end up with a positive 3 here, which is exactly what we were looking for. Okay, now since we have exactly the same thing here left in the parentheses, 2x plus 3, 2x plus 3, the distributive property allows me to bring this 5x minus 7 together. So that's what I can do. I'm going to move my 5x minus 7 together in parentheses times 2x plus 3. Now hopefully you can see that if I distributed this back, I end up right back with 10x squared plus 15x. And if I distribute this negative 7 back, I end up exactly with negative 14x minus 21x. And likewise, if I distribute all of these terms together, you're going to end up right back where we started from here. So we have equality maintained. Now, the zero product property says that if I'm multiplying two things together and I'm getting 0 out, then one or both of those two expressions must be equal to 0. And that's what allows us to put each of these factors equal to 0, and then it becomes quite an easy equation to solve. So I've got 5x equals 7, and x equals 7/5, and 2x equals negative 3, and x equals negative 3/2. And so what we just solved there is, if we turn this into a function and we graph that parabola, we found the two x-intercepts to be x equals negative 1.5 and x equals 2 2/5. So that's exactly where that parabola is crossing the x-axis. We also see, just reinforcing previous concepts, the stretch is 10. It's very, very large, and it's positive, so this is an upward-facing parabola. All right, let's try it again. This time I'm writing a function, and the directions say find the x-intercepts of this quadratic function. So this is a parabola, downward-facing with a lot of stretch. And if you see this and I say find the x-intercepts, I want you to know that what you're doing is replacing that output with 0. Now I like to have my 0 on the right side, so I'm going to flip this over here and put all of these terms on the left, and I'm going to put my 0 over here on the right. What allows me to do that, by the way, is the symmetric property of equality. Okay, as I mentioned before, try to factor out anything out of these numbers that will make your math easier. We can't, unfortunately, here. So we're going to identify what our A is, our B, and our C. And the procedure is to find the product of A and C, which is a positive 84. We're looking for factors of 84 that are going to sum to 44, or B. And if you can't see that right away, you're going to take a real systematic approach. 84 times 1, 42 times 2, etc., and go all the way down. But I'm going to cut right to the chase. And we've got 42 times 2. It's going to give you the positive 84, and they sum to 44. Now we're going to replace our 44x here with the sum of 42x plus 2x. Doesn't matter which order you put them in. I think I'm going to put my 2x over here with my negative 12x squared, and I'm going to put my 42 over here with my negative 7, just because the factoring by grouping step looks a little bit more natural there. However, as I said, it really doesn't matter what order you put them in. Okay, so I'm going to start my factoring by grouping. In the first two terms, I can take out a 2. and I could take out an x, and I end up with negative 6x left and a positive 1. And out of the next two terms, I could take out either a positive 7 or a negative 7. Because of the decision that I made over here and not taking out a negative 2x, and I ended up with a negative here on this term, that's going to tell me that I have to take out a negative 7 here. Let me just rewrite that. And so that would turn into a positive 1. And I've got negative 6x plus 1. And I obviously made a mistake here. This should be a negative 6x. Negative 6x plus 1. So both of these are the same, and the distributive property allows me then to bring the 2x minus 7 together. And negative 6x plus 1 equals 0. Zero product property tells me I could put both of these factors equal to 0 independently and solve. So I end up with x equals 7/2, and I end up with x equals 1/6. So what I just solved there are the x-intercepts of this particular downward facing parabola. Okay, so the last section of the notes that I went over in this section is probably brand new to you, where we start with knowing what the x-intercepts are, knowing what the a point is on that particular function, and going in reverse and then writing what that full function is. Okay, so as you recall in the notes, if x equals negative 3 and x equals positive 6, if I were to turn that into a factor, then I would have x plus 3. In other words, if I put x plus 3 equal to 0, I'm going to get my negative 3. And if I were to turn this x equals 6 into a factor, I would have x minus 6. Now we're going to have some kind of stretch here in front, A, and that's going to be the general form of our equation. As I mentioned in the notes, there's an infinite number of functions that I could write through any given x-intercept. I could have all kinds of different stretch values. I could have downward facing, different stretches, infinite number. So just knowing the x-intercepts is not enough to write the function. However, if I were given a particular point that is on our function, then I can certainly find what that stretch factor is. So this is an x, and that is a y, and I'm going to substitute and actually solve for a. So I'm going to replace my y with a negative 5, and I'm going to replace my x with 7. So I have a negative 5 equals a times 10 times 1. Our convention is to put the coefficient in front of the variable, and I'm going to divide both sides by 10, and I end up with actual compression and a reflection over the x-axis because it's negative. So our final function here is y equals negative 1/2 times x plus 3 times x minus 6. We could leave it this way, but if I said put it in standard form, then you're going to need to go ahead and do all of the distributions. So the easiest way to do that is to just keep that negative 1/2 out front for now and go ahead and do all your distribution. X times x is x squared. X times negative 6 is negative 6x. 3 times x is positive 3x. And we end up with a negative 18. And just combine like terms here. And then just distribute that negative negative 1/2. So negative 1/2 x squared, positive 3/2 x, and positive 9. So this would be the final function in standard form. Okay, sorry that you missed this during class, but I hope this video helps.